All right, so here we are with the part 2 of 9a. We're looking at situations and expressing the given function in words, and you are to write the two variables as an ordered pair. And I'm going to go back to the notes at this point so we can do these problems. All right, you are writing in a hot air balloon. As the balloon rises, the surrounding atmospheric pressure decreases, causing your ears to pop. So what we have are two variables that aren't time, are they? Neither of the two are time. You're writing in the hot air balloon, the balloon rises, so that's going to be altitude. The surrounding atmospheric pressure decreases, so pressure. So we have altitude and pressure as our variables. Does the pressure depend on the altitude, or does the altitude depend on the pressure? All right, well, the altitude is the independent variable because the pressure that you're experiencing, the atmospheric pressure, is dependent on how far up you are, what your height is, your altitude. So in this case, it's going to be altitude and pressure. All right. And then B, you're on a barge headed south down the Mississippi River. You notice that the width of the river changes as you travel southward with the current. And as you're traveling southward, I'm going to probably call that distance from the source. All right, and that's how far away you are from the source of the river. So we have the river width, and then you have the distance from the source. So does the river width depend on the distance from the source, or does the distance from the source depend on the river width? The river width is going to be dependent, right? The river width depends because it's cut out more as the water flows. So we're going to put that as our dependent. So distance from the source is first. And then river width is second because distance from the source is independent, river width is dependent. All right, last one. You run different distance intervals on a track, and you want to know how your heart rate depends on the distances you run at a fixed speed. So we have distance and we have heart rate. All right, so distances at a fixed speed. So you're running, 8-minute miles, and you run that for a mile, and then you look at your heart rate, and then you run an 8-minute mile for 10 miles and look at your heart rate. Your heart rate's going to change with the amount that you're running. So your distance doesn't depend on the heart rate. The heart rate depends instead on the distance. So heart rate depends on the distance. So distance is going to be independent, and heart rate is dependent because that depends on the distance. All right. Okay. So representing functions. We're going to go back to our PowerPoint here. Representing functions. There are three basic ways to represent a function. You can do that with a data table, okay, just a table of values. And the table actually provides a lot of detailed information, but it becomes really unwieldy when we have large quantities of data. So the more data you have, then the table is less useful to you. Sometimes it's better to have a graph of the function. That's a picture of the information of the data. So the graph is easy to interpret and consolidates a great deal of information, so it's a little bit better than a table, and it's absolutely more visual, and that helps a lot of people understand the data better. And then the last thing is an equation. You can write a mathematical representation of the function in the form of an equation. Some people like that. Now, our domain of the function is a set of values that are independent, so anything that can go into the first value. So independent variable will be the domain, and then the anything that can go in for the range of a function consists of the values of the dependent variables that correspond to the domain. So for instance, which would be the best one? When you're driving a car, the distance the car has traveled after various amounts of time, your time would be the domain, and it can be anywhere from 0 because can't drive a car in negative values, so it would start at 0 and then go up to, 10 hours, whatever it is that you're driving. And then the distance would be 0 miles to, 800 miles, whatever. So domain and range are tied to those independent variables, and that's important to note. All right, so if you're creating a graph, first you're going to want to identify the independent and dependent variables of the function. Then you want to identify the domain and the range of the function. So that's so that you can put the independent variable on the bottom, and you can set your units of the domain. And then your range, you want to put those values, figure out what that dependent variable is, and put those on the vertical axis. And you need to figure out what the units are and where it starts and where it ends. So use the information to choose your scales and your labels on the axes, and then zoom in on the region of interest to make the graph easier to read. Eventually, you're going to be making the graph using the given data, so you'll be looking at your points, your data points that you're given, and then mark them appropriately, and then fill in any gaps between the data points, especially if it's time, because time never stops, so you want a continuous graph with those. Before accepting any predictions of the model, for the last step, you need to be sure to evaluate the data and assumptions from which the model was built. Sometimes you have functions that only work for a certain amount of time. They don't work for anything beyond a set value. So your domains and ranges are very important. You have to set those, and then those are specific to the equations or to the graph and to the model, and we can't assume anything beyond what we're actually given. All right, so first example I'm going to do, and I think it just gives you your answer on your notes, if I remember right. Sorry about that. All right, write a short statement that expresses a possible relationship between the variables volume of a gas tank and the cost to fill the tank. Now, the greater the volume of the gas tank, remember, the more money it costs to fill up the tank. So that's basically what it is. As the volume of the gas tank increases, the cost to fill the tank also increases. Okay, and that's what you would write. And that's already filled in your notes, so woohoo, you don't have to fill that in. And then we're going to go to the paper to do the next function. The data table that you see here represents the function and shows the average high temperature on certain days of the year. So you have January 1st, note they're all the first, and then you have December 31st. And there's quite a difference between December 31st and January 1st, even though they're a day apart, right? 4-degree changes, but there are several times where we have at least a 4-degree change in the temperature. Anyway, what you're supposed to do is identify independent and dependent variables, describe the domain and range, and then make a clear graph and describe the function in words. And this is very similar to something you would get on your homework, and that's why I wanted to go through it, is to help you with that, figure out your homework. So first thing, identify the independent and dependent variables. What you have temperatures based on dates, on time. So this is time, and this is temp. All right, so the temperature that it is depends on what time of the year it is, right? Not the other way around. So time is independent, and temperature is dependent. All right, so that's pretty simple. Describe the domain and range. So for the domain, all right, that's going to be all the days over the course of the year, even though we've only listed so many. The domain is going to be all days over the course of the year. All right, and then the range is very easy to spot. What's the low and the high? That's what we're going to write down. The low temperature is 39 degrees Fahrenheit to the high, it's going to be in here, 84 degrees Fahrenheit. So that's your range. The range of temperatures on this particular year and over just the course of the year will be 39 degrees to 84 degrees. All right, making a clear graph of the function. Now, this is going to be 1st of January, and I'm just going to write these in. You can just put months in because our domain are all the days over the course of the year, and domain goes along the x-axis. So January, February, March, April, May, June, July, August, September, October, November, December. Now those are all the first, and then we have this last one, December 31st, don't we? And then the temperatures ranges go here. Now, I would probably start at 20 and then go up 30, 40, 50, go up by tens, 60, 70, 80, 90. And that's as much as we're going to go. We don't need the top two notches that way, but going by tens is sufficient for this type of range, 39 degrees to 84. So notice that you have your time, which is independent along your x-axis, and then you have your temperature, which is dependent along your y-axis. And then you can just go ahead and mark them. So 39 is going to be about right there. 40, 48, 55, 68, 79, 84, 82, 82, 64, 56, 46, that's really dropping there. And then the last day of the year was 43, right? All right, so you can kind of see we're increasing, and then we start decreasing heavily like that. All right, very clear graph of the function. I kind of missed that a little bit, but that's all right. Fix it. Describing the function in words, it looks like the temperature increases during the first half of the year and then decreases during the second half of the year. And that's what you would pick. And you can write that down. Increases first half of the year and then decreases the second half of the year. All right, that's 9A. Good luck. Get your homework done. Hope you have a great time doing it.